I got nothing jazzy today. Let's get started. All right, this is Norse Teaches Science Biology Edition video. We're going to continue in talking about genetics today, starring me, Mr. Norse. Today we present, or I present, Punnett Squares, preferably complete dominance Punnett Squares. So I can use and analyze Punnett Squares to determine possible genotypes and phenotypes. So if you haven't watched the genotype phenotype video, I would go back and watch that first because you'll need to know that material to do this, because in genetics, everything builds upon itself. So what are Punnett squares? Punnett squares are tools used to predict the likelihood of a genotype and phenotypes of offspring of both parents. It's a predicting tool to see what the offspring may look like. Now, things do happen that it's not right, but that is what Punnett squares do. You see to the picture over the side, this kind of idea of a Punnett square looking at purple flowers where sometimes a white flower just happens to come into existence. So, analyzing Punnett squares. Once you do a Punnett square, you're going to have to analyze Punnett squares, and we're going to use something called genotypic ratios and phenotypic ratios. So this one's genotypic ratios, and how you do this is you would list out all the genotypes that are inside of the Punnett square and what ratio they have. You can write it multiple ways. You can write it a 2 to 2, half, half. I like to write percents. And the reason why I like to write percents because the whole Punnett square is 100% and each box is 25%, and it's a simple idea for me to look at. But it's up to you how you write it. But when I do this video, I will be using percents here. Phenotype ratios are done about the same way, but you have to write the actual phenotype. So instead of writing the letters, you're going to write the actual trait. For this sense, it was tall and short. So that's how we would write phenotypic ratios, all based off how they're actually going to look. Now, this is all kind of, you're like, what? It's going to get, you're going to understand it when we do the examples. This is something that you're going to have to just see to understand how to do it. Now, Punnett squares and probabilities, remember I said it's the possible outcomes. That's what they do. It's not what actually will happen, it's what could happen. Sometimes genetics goes crazy and something that shouldn't happen happens, or mutations happen. So this is just a probability. Don't count on it. So if you're out there, girls, and you're looking at a guy and you're like, oh, he has such nice eyes. I hope our kids have those eyes. Stop doing the Punnett squares in your head. You don't know what's going to happen. All right. So we're going to solving complete dominance Punnett squares. So we have this question. It says, in dogs, having dark fur is dominant to having light fur. So dominant in the dominant trait is dark fur, and since it's dominant trait, we're going to use the letter D. And light fur is the recessive trait. That's a lowercase d. We're going to cross a heterozygous female dog with a homozygous recessive male dog. So the female dog is heterozygous. You write that a capital D and a lowercase d. The male dog is homozygous recessive. Homo means same size. Recessive means lowercase. So the male dog is lowercase d, lowercase d. So the first thing you do, you have to determine these genotypes of the parents. After you determine the genotypes of the parents, you're going to write the female genotype on top of the Punnett square like this. So you're going to place one letter here and the other letter here. The male you're going to place down the side, one letter in front of each box, like you see here. Now, this is how I do mine. I like placing the female at the top and male down the side. It really doesn't matter as long as you place one at the top, one at the bottom, but I like doing this so I can see it better. So when you have that, in each of the empty boxes, the letter on the top will come down and the letter from the side will come over. And when you write them, just style-wise, you always, if there's a capital letter, you write that one first. So this box here, the lowercase d is going to come down. The capital D is going to come down, and the lowercase d is going to come over. And you're going to get capital D, lowercase d in this box. All right. If we continue down, the capital D is going to come and be here, and the lowercase d is going to come over like this. All right. Then this box here, lowercase d is going to come over, lowercase d is going to come across, so we just write two lowercase d's. In the last box, lowercase d is going to come over, lowercase d is going to come down, lowercase d, lowercase d. And so we solved the Punnett square here. Now we're going to write our genotype ratios and our phenotype ratios. So we're going to start with genotypes. So if we look in here, the first genotype I see is a capital D and lowercase d. How many boxes has capital D, lowercase d? Well, I see one box and I see two boxes. Since there's two boxes, that would mean 50%, because each box is going to be 25%. So we cover those. The next one I see is a lowercase d, lowercase d. How many boxes have lowercase d, lowercase d? Two. That means it's 50%. Now, to see if you need to go back over to Punnett squares, if these do not add up to 100%, you have missed a genotype. But if these add up to 100%, you should be good. 50 plus 50 is 100, so we're good there. The next thing, phenotypes. What are the two traits that you can have here? You can have dark fur, or you can have light fur. Right? To have dark fur, you have to have capital letters. To have light fur, you have to have all lowercase letters. So if we look over here, how many boxes have a capital letter in them? Two. That means dark fur is 50%. How many boxes have just lowercase letters in them? Well, two. 1, 2. That would be 50% here. You can double check yourself as well. These numbers should add up to 100%, and they do. So this is the first practice on Punnett squares. All right, let's do another practice. I want you to pause the video here, and I want you to try this on your own. 5, 4, 3, 2, 1. Hope you pause. Let's go over it. So it says, in dragon lizards, which are fake, I made them up, you have aqua spots are dominant to red spots. So let's stop right there. Which one's dominant? Aqua. So we're going to use A because that's the first letter of the dominant trait for this Punnett square. Aquas are dominant, so they're capital A. Reds are lowercase, so they're lowercase a. We're going to cross a heterozygous female with a heterozygous male and write our ratios. So the female is heterozygous. What does the prefix hetero mean? It means different. So we're going to write that capital A, lowercase a. The male is heterozygous as well. So the male is going to be capital A, lowercase a. Now that we have identified the two parent genotypes, we're going to write them in our Punnett square, on top of our Punnett square and down our Punnett square. At the top goes the female. The female is capital A, lowercase a. Down the side, the male is capital A, lowercase a. Then we fill in our Punnett squares. In this box, first box, capital A comes over, capital A comes down, capital A, capital A. In this box, it would be capital A, lowercase A over, A down. This last one, A down, A over, capital A, lowercase a. The last box, lowercase a down, lowercase a over, lowercase a, lowercase a. So we filled in the Punnett square. First thing we do our genotype ratios. First genotype I see is capital A, capital A. How many boxes have capital A, capital A? 1. So that's 25%. Next one I see is capital A, lowercase a. How many boxes have capital A, lowercase a? Well, I see 1. I see 2 boxes. So if each box is 25%, 2 boxes would be 50%. The last box I see, because I know this doesn't equal 100 yet, is lowercase a, lowercase a. How many boxes have that? 1 box. That's 25%. So if we add these 3 numbers up, we do get 100%. We should have gotten all the genotypes from the Punnett square. The next one, the phenotype ratios. Your 2 phenotypes are equal, either aqua or red. So to have an aqua spotted dragon lizard, you have to have at least 1 capital letter in the genotype. So if we look in the Punnett square, how many boxes have at least 1 capital letter? Well, this box does. This box has a capital letter in it, and this box has a capital letter in it. That's 3 boxes. So 3 times 25 equals 75%. To have red, you have to have a box that does not have a capital letter in it at all. A genotype without any capital letters. Now look, I only see 1 up here. The little a, little a. So that's 25%. Add these numbers up, that's 100. So these dragon lizards have a probability 75% chance of having aqua spot dragon lizards, and there's a 25% chance of having a red spot dragon lizard. So that is Punnett squares for complete dominance. We're going to talk in other videos about how Punnett squares and these things can change when it's not always a complete dominance to it. So, like I always say, I hope you learned something. Go practice this because you're going to need to do some more practice. And this is Mr. Norris, and he is signing out.